Hello team, today's challenge is blood bank, where we're given two arrays, the array of blood that we have in the bank, right, individual pints, and the array of patients that need blood. And we need to try and match these up in the most efficient way possible so that as many people can get the blood that they desperately need, right? So we have all of our donors over here. They've helpfully donated blood. We have our receivers over here. This isn't actually the first time that we've seen a blood-related coding challenge. That was over here, the blood type compatibility, where we had not only the blood type, right, the letter rules, but we also had the RH rules. Today we aren't dealing with that, but if they ask for it at a later date, we might be able to use the code that we create today and just build into it. So keeping that door open, making it pretty safe. And in fact, later on, once we get far enough along, there will be a part of this code right here, that we can actually borrow from. So some interesting stuff, right? We can lean on old code, and that is perfectly okay. So back to the challenge. The first step is, how are we going to get the blood out of the bank efficiently? And the simplest way is to sort it from easiest to use to hardest to use, right? Specifically, if a patient comes in and they are AB, we want to grab an AB blood first, right? If we have it, great. If they're AB and we don't have any AB blood, then they should grab an A first, right? And if we don't have A, then B, and then finally O, the universal donor, right? So by sorting it, we very efficiently go through that list and reduce it down as we're iterating through the different patients. Okay. With that in mind, we are over here. So let's get that sort going. Okay. We'll call it sorted bank. That seems pretty good. And we'll set up the bank dot to sorted. Now, to sorted returns a brand new array, which is why I like it. If you aren't able to use to sorted, or you have to go a different way, then my advice is do whatever you can to create a brand new array. Especially in JavaScript, that array is being passed in by reference, which means any changes we make to this, including sorting, get passed back up the chain and are side effects in future code. So just be aware of that. We want to return something brand new. We're either going to use toSorted, or we're going to expand this out and create a brand new array. Okay. Now, toSorted will take some sort of a function, a callback. Okay. I don't want to do that right here. It's going to make this code very long. And I feel like this is something that we could refine in the future or refactor this specific function. So I'm going to move it out. Instead, I'm going to call that, what did I call it? Compare blood types, right? Blood type, like this. We don't pass anything in. We just send it through. When it calls the sorting function, that's when it calls the callback. Okay. So that function is up here. We have compare blood types. We get A and B, not to be confused with our blood types, which are capital A, capital B. That's not really important today, but it's important to know that this is just an item. These are just two items that we compare. And when we're doing sorting, we usually default to A and B. So don't let that confuse you. These are not blood type related variable names. Okay. Inside of here, we do three things. Okay. If A equals AB, okay, then we want to return -1, which is kind of like saying leave it where it is, right? We don't want to sort that at all, which is perfect. If B is equal to AB, then we want to return +1, which will shift it closer to the beginning of the line, right? That's kind of what we're going for there. So these, A stays where it is. We want to ensure that all the time. B needs to move. It needs to move closer to the front. Otherwise, we just do a local compare. So if it passes through these, then we return A dot locale compare. So locale compare of B, okay? And that should do it, right? So again, we want to push AB to the start of our line. And if we don't do something like this, or a variant of this, there are plenty of ways to get this done. then AB will actually come after A, at least in the English language. A comes first, then AB comes next. So we want to push AB to the start, then it will be A, then B, then O, which I'm pretty sure at least once in this video I'm going to misquote as 0. Don't let me do that, okay? But this gets a sort done, which means that now we have this sorted bank and we can go through and find the first available that matches our receiver, our patient, okay? So with that, we go down here and we set up our counts, okay? Our counts are going to be 0, and we're going to go for let patient of patients, because it's an array, not an object, right? So we use of here. And the first thing that we do is we find the index. We want to find the index because we also want to be able to alter sorted bank in a few seconds here, okay? So using the index is going to let us splice into that. And that's the key to this, okay? So const blood index is what we're going for. And that is going to be the sorted bank, okay? Sorted bank dot find index like this. What are we doing? We're doing type. We're going to send it into our callback and do something. What are we doing? Well, we're returning either type equals O. Like we've gotten so far down the line that all we have is type O, universal donor, right? So we can use that, take it, okay? Or outside of it, or patient like this dot includes what? Well, it includes a type, right? And this bit of magic is basically makes a thing run, okay? So if you imagine our patient being AB and our blood type being AB, well, AB is included in AB, not a problem. If our patient is AB and our type is A, right? Then A is inside of AB, that works. If B is inside of B, that works. If O, well, O is caught out here, so that's not a problem. But if you reverse it, then things get very different, right? You have patient with type A. Well, AB is not an A is an A, B is not an A, right? And of course, O always works. So this gets us to that index. But what happens if we don't? What happens if we've gone through the whole find index set and we didn't find anything? Well, it returns -1. Okay, and that's very important because down here we need to test if blood index is greater than -1. That's when we do stuff. Okay, if we tried to access -1 in a few seconds, that would actually go to the end of the line. But we didn't actually find anything. So be careful with this -1. Okay, don't skip this conditional. Inside of here, we go count plus equals 1, because that's what we're doing today. We're just counting it up. If we were trying to capture something or put it in an array, then we could push, not a problem. And then here we go sorted bank dot splice. Even though sorted bank itself is not mutable because of the const, we can change the elements inside of it. And that's what splice is doing. So we're going to splice on blood index, if I could type just like this. And the question becomes how many, right? Well, it's only one, right? The second argument is not an index. It's the number of things that change. If we included a third argument to splice, then it would actually replace 1 with whatever this is, okay? Because we aren't doing anything, it just deletes them. It gets rid of them completely. So we're saying blood index, delete 1 or alter 1 to be nothing, right? Just blast it into the void and get on with it, okay? And then from there, of course, we come down here and we need to get our string on. Okay, I was about to put count in there, but I forgot for a second that we have a string that we need to return, okay? So right here we have this string, the number of total patients, that's pretty easy. That is just patients.length, right? And x is our count. So right here, count, and that does it, okay? Now I hinted that part of this we could actually borrow from old code. And that part is right here because this type equals O and patient includes type is exactly what this does. So is type compatible? We have the donor type, the receiver type. We test it, we send it through. We can actually bring this over to our code, pasting it right in between here. And instead of this bit, right, where we are sending stuff in, well, we can just return something else. So right here, I'm going to comment this out and return what? Well, it is type compatible? Probably should have copy and pasted that, but that's okay. Again, donor type and receiver type. So the donor type is coming from the bank and the receiver type is the patient, and everything still works. So if you were doing this professionally and you already had access to this, bonus for you, right? You can absolutely reuse that code and save yourself some maintenance costs, right? But this is it today, right? We jumped through it. So we set up a sort, and the sort allows us to very efficiently move items out of the bank, starting from easiest to use to most difficult to use, right? Getting it done. And then from there, we went through our patients. We tried to find blood that matched. And if it did, then we incremented the count and removed it from the bank, at which point we did it all over again until we ran out of patients. At which point we know how many patients we can actually help, along with how many patients there were originally, sending it out the door, and it works. Okay. Very serious stuff, donating blood, very serious stuff, but writing the code, hopefully not, right? And that's where we are today. So a little bit of a sort. Again, plenty of ways to do this sort. I'm sure that someone might actually comment that there's a more efficient way to do sort. There absolutely is, right? We could replace locale compare with something a little bit more not succinct, but a little bit more efficient, right? It'll take a few extra bits to get there, but a little bit more efficient, a little bit more performant. There are ways out there. And then down here, reusing some code and doing the thing and making it work, okay? With all that said, do you like it? Do you hate it, right? Did you find a different way? Please share all that in my comments. Otherwise, today, this has been Blood Bank, the second blood challenge that I think we've done on FreeCodeCamp. And I will see you tomorrow.